Welcome back to Hard Hat Chats. This is the 6th edition of this mini-series about the construction of the new Carolyn Small School and the addition at Mabel I. Wilson School. So I'm Jeff Porter, the superintendent of MSAD 51. I'm your host for these series. The Hard Hat Chats series is intended to keep you informed about the One Campus project as construction continues over the next 12 months or so. During previous editions and episodes of this series, you've had a chance to hear about the progress at both this school and down at Mabel I. Wilson School. And at this school, specifically, we've been talking about the foundation, the pouring of the foundation, the steel, the formation of the building. And as you can see behind me, that formation is getting close to being completed, at least in terms of the steel being put up. You've also had a chance to hear about the design of the architectural layout of this building and how the design of the building has translated into the actual construction, the physical construction of the building that's behind us. And last time we checked on the activity at the Carolyn Small School, only some of the classroom portion, which is the back part of this building, was formed. And so today you can see that the common areas of the building, the gym, the cafeteria, the steel is now up, and you can see the formation of those parts of the common areas of this building. In addition to the underground utilities and the wiring and the piping, those are things that have been going on during the course of the formation of the building. And those are things you don't quite see when you're looking at it from the outside, but those are very critical components to the work that's been completed over the last couple of months. So we'll hear more in this segment about the brick veneer as well down at the Mabel I. Wilson School addition. So you'll have a chance to start seeing that and hearing about what it's going to look like as it goes up over the next few weeks. So today, high school student Camden Burke, who's also been your co-host during this series, will chat with Great Falls contractors about the progress here at the Carolyn F. Small School. So welcome back to our series and enjoy the rest of our episode.
Welcome back to episode 6 of Hard Hat Chats. I'm welcome with Bob again.
Yeah. Jake.
And Travis.
Yep.
Today we're going to go over exterior envelope and the brick veneer on the schools. So for the envelope, what is exterior sheathing?
So this sheathing in general is just like a cover of the framework. So the exterior would be, you have your studs and it's on the outside of the building on those studs, your framework. Exterior sheathing kind of acts as usually like a backing for your siding, the material that's going to be exposed to the weather. And backing is in being able to just fasten. Usually want to still do it on studs, but it really helps with the exterior sheathing. And then also there's different products for exterior sheathing, but most of them, just about all of them, are also a supplement to weather protection. And it's really also to kind of make sure that the material itself holds up, not just keeping stuff out of the building, but making sure that the material is not degrading, as that would start getting your siding to fall off or be compromised. So,
What is this product made out of?
We're using a product called dense glass. That's the yellow sheathing that you see put up, and it's like fiberglass mats and gypsum compressed together. It's a real durable product, pretty dense. Water doesn't really affect it as much compared to like a wood, plywood or OSB wood. So yeah, good for commercial products.
And then is there such thing as interior sheathing?
We use plywood sometimes inside, depending on rooms that maybe require a lot of shelving or something that would need support afterwards once the drywall goes on. And drywall would be considered an interior sheathing.
Where does this product come from?
Plywood I mean, that's a standard, almost standard, but pretty much a standard wood product, and the U.S. kind of sources that from. You have your, I think, Douglas and fir in the Northwest in Canada, and then Southern pine from the South.
We have mills right here in Maine that make Advantech sheathing, which is a very popular product. Um, not exactly sure where the plant is, but they're just producing tons and tons of sheets a day and shipping it right out immediately. They don't even warehouse it; they just produce it, put it on a tractor trailer truck, and send it. So a lot of plywood comes right from northern Maine.
Do window and door flashings butt up, or are they just fashioned to the sheathing?
Um, there's different types of flashing that we use here. I mean, some of it is the actual air vapor barrier that would go, you know, over the flanges of the windows. Then there's some metal flashing that would go to the sheathing. Depending on the scenario, it would get nailed to it or screwed to it.
Is there room for expansion gaps, or is it just butt tight?
A lot of times, in most cases, there's room for an expansion joint. Just material moves around so much, so even if it's trim or casing close to a window, there'd be a gap, and then an expansion joint, which in that case would probably be a caulking.
At Maybelline Wilson, we have a 3-inch where we go from existing to new. We have a 3-inch expansion there on everything from framing, dense glass, and also the brick veneer. Obviously, the existing building has been, everything settles, right? So that's been moving for years now. Where we've just added this addition, that's going to have a chance to move and do its thing for a little bit. So that expansion up against that existing will allow that to move and do what it needs to without really interrupting that connection much. And then we also do, I think Bob touched on it a little bit, we do have expansion joints in the framing, but also in the framing we have deflection track, so it allows deflection and things to move a little bit. But then we also have expansion joints in the dense glass, so there are joints in that will allow that to move.
Even in the gypsum, right?
Yep.
In the drywall,
Yep.
However so many feet, you need kind of it's called expansion. It might be called something else, but it's like a
Control.
control. It's like a purposeful gap between the drywall sheets.
Long spans, you need that ability for things to move.
Yeah. So it's like, I think it's usually vertical, right? So you have your sheets horizontal, like landscape mode, and then it's usually like in a long, wide wall, you have a vertical one.
What is an air vapor sheet, and how does it go along with the exterior sheathing?
So I'll take that. So we're using, it's a product from 3M, air vapor barrier. It's just it's a self adhering product. Comes in rolls. They stick that on. There's a required overlap on that stuff. So they're applying that to the dense glass and rolling that to get as many air bubbles and everything. Obviously they want to minimize the air bubbles and keep that nice and flat so that we get a good seal and all that stuff.
I think we also, it's 3M, but there's two different products that we have for air barriers. One's non-permeable, which doesn't allow water vapor to pass through in the air. And that's, I think, goes on like all of our walls up to a point. And then I believe we have a permeable one that does allow water vapor, both by 3M. And that one's, I think, at the top, kind of by the parapet soffit area, kind of just to allow vapor to escape. And I do know we have two different ones that our installers have.
I know you touched on this a little bit, but how does the air vapor sheet compare to like ice and water shields?
The Grace Ice and Water Shield mainly meant for roof applications. Um, a lot like very less permeable, like water can't go through. It's a self-healing product too. If a nail or screw goes through it, it seals to it. So it's not really designed to work as a necessarily an air vapor barrier.
That's also a bituminous product, so so it has bituminous in it, whereas the air vapor barrier is just a sheet with adhesive on the back. So that grace will um, you can stick that. It doesn't stick super well, so sometimes you have to reinforce that. But once the heat gets to that grace, it really cooks that stuff onto that product and becomes one with it. So
For the brick at MIW and the brick at the school here, what type of mortar is being used?
It's a Type N mortar. Is what it's called. It's non-structural.
How is it created?
So mortar and grout are a little similar. Both are like mixes with cement, which is kind of a cement itself is a mix of grounded up like earth materials like shale, clay, sand, limestone, and that cement is then mixed with ours is we use spec mix, and they have their mix is cement and specific, especially treated limestone. Um, it's it's called lime or like a mortar lime, and that's mixed with the cement and sand, grounded up sand from I'm gonna assume uh, recycled materials like recycled brick and mortar. Um, but yeah, it's just all a big mix, and you put water in it, and gets being able more fluid and able to place and form it, and then it cures. And it's ours is non-structural, of course, so but it's enough to keep the brick in help in place and have a solid form for the wall.
What brick is being used for this project?
A couple different kinds of brick, actually. Mostly clay. It's a clay and shale.
Yeah, there's like a smoother face, and that's like is the mango. That's up here.
Yeah.
But down there we have the beige and then the old red brick, which I think is the old port from Morin. But I think that one is the FBX, which is the more durable, consistent size. And then the beige is like FBS, which is like a clay and shale face one. Um, and those are, I think, general standard types of brick. We have FBS and FBX, according to our spec.
Where does this brick come from?
So I had to look this up. Because generally, you're not so sure of where stuff comes from. So we have Morin has a plant in Auburn, Maine. According to Google. And then Belden is based out of Ohio, and Glengarry, I think, is like a sister company to Belden, but they're out of Pennsylvania. And so we have two different types of brick from Morin, and that's the red on the Mabel Wilson, and I think same as up here with the red.
I think so, yeah.
And then the mango glaze that's up here is I think Glengarry. And then Belden is the beige you'll see on the edition.
Does the brick veneer add any structural integrity to the building, or is it just for looks?
No, just for looks.
Just for looks. In fact, it has to be supported by. It's anchored to the sheathing, which is anchored to our framing, which is supported by our structure.
And that's right in the name, right? When we say brick veneer, it's a veneer, so it's just added to the structure.
Yeah, like if you go to old houses that are like structurally made by brick, their walls are probably like a foot, right? It probably has like at least 3 to 4 bricks deep in the wall. This we have like one, or is it one?
Yeah.
It's just one single brick stacked up.
How long does the brick veneer process normally take?
I mean, it depends on how many people you have, right?
Yeah.
But in the area you can run. I would say it depends on that. These guys that have started down at Ray Wilson have been doing. They can do probably a couple feet in a run.
And yeah, and talking on that, so our brick goes all the way around. They kind of have to keep it at the same level as they go, because they need the courses to all line up. So you can't like segment it at all. So they have to do the whole building course by course by course, and they'll do like Jake said, 2 feet a day.
It would go faster in walls that have less windows too.
If people walk by or they're driving by during this process, what type of equipment will they be seeing out there?
So they're using pipe staging to get up. Obviously, our brick height there and also up here isn't all that high. Right? We have a brick cap which terminates our brick to then hardy siding down on Maple Wilson, and then up here the brick cap, it'll be brick to the cap, and then from that above will be metal siding. So sometimes they'll use what's called hydros, which is a mobile unit that they can lift up and down. Here they'll be using pipe staging because it's not all that high. They also have their saw that they're cutting the brick veneer with. They have their
Is that like a chop saw?
right, their mixer and their silo.
Yeah.
Set up to mix up their mud and stuff. So
Do they just use like a chop saw for the brick?
they have a saw that they're using. It's like a larger tile saw like that.
What happens if the moisture gets in between the veneer and the wall of the building?
So it's designed with the air vapor barrier. The moisture will terminate at the air vapor barrier, and gravity will make it drain. It'll drain all the way to the bottom to the brick shelf, which is pitched.
Yep.
And has drains and can exit through that. It won't get trapped.
How well will the new brick veneer at MIW match the existing brick?
It's going to match pretty good. It's not going to be perfect because the age and of the existing, just weather, sun. I mean, it doesn't do a ton to brick because it's a pretty rugged material, but it does fade a little bit, and puts courses down at the bottom that get splashed back from the rain, that gets dirty. But eventually, over time, you won't notice really much of a difference over time.
And then will they color the mortar to match the existing weathered mortar, or is it?
It's close. It's more of a standard color for
Yep.
that color brick. So again, the new addition's just going to seem just a little bit brighter for a little while.
Thank you for watching. We'll catch you on the next one.